All right, good afternoon, everyone. Hope you're having a good reInvent. Welcome to this session, Migrating SQL Server, Databases to AWS, Best Practices and Patterns. My name is Prahlad Rao. I'm a Solutions Architect at AWS. With me today, I have Jerry, who's a Principal Systems Engineer at Expedia. I know that this session is between you guys and the beer, so I'll try to make it as useful as possible for you so that you have some key takeaways from this session. So this session, we are trying to focus on the what and how to do it. For example, what are the things to consider when you're looking at migrating SQL Server database to AWS? What are the migration tools, options, methods, and technologies, rather than why? So we are focusing on more on the what and the how, rather than on the why. So the why aspect is, why are you needing to move SQL Server to AWS? So I'm assuming that some of you have already made some of the decisions to kind of migrate, or at least looking to migrate databases to AWS. So we'll focus on some of the migration tools, practices, methods, so that when you actually begin the migration, you will have some key points from this session to be able to apply to your migration. So we are going to begin with taking a look at SQL on AWS services. Essentially, what are the options if you decide to run SQL on AWS? Running on RDS versus running on EC2 instances, or maybe a combination of hybrid architecture connecting on-premise to AWS. So we are going to outline some of that. And we're also doing some compare and contrast of if you run SQL Server on RDS versus EC2, what are the things that you get and probably lose as well. So trying to compare and contrast which platform might be best suited for your needs. As with any Windows environment and SQL database environment, authentication is critical. So we want to make sure that we cover at least a high level of SQL authentication options when you're running on AWS. So we'll take a look at that. And then outline some of the different migration options when it comes to migrating data. Not only just migration, you can also think about, let's say you want to replicate the data from your on-premise SQL database to AWS, maybe as a backup, or maybe as a disaster recovery service, or maybe even to make the database available for your data analytics team to be able to get insights out of your database. So for any reason, it doesn't have to be just for pure migration, but we'll also outline some of the replication options as well. AWS Database Migration Service is one of our key components to be able to migrate databases, not only homogeneous database migration, that means like-for-like migration, but also heterogeneous data migration. If you're looking to move away or migrate from commercial database engines to more open source, maybe Postgres, MySQL, or even Amazon Aurora, we'll take a look at some of the key features and capabilities within the database migration service that is turning to be a key component for large customers who are trying to move databases to AWS. The database migration service gives the capability of not only having to migrate from or migrate and replicate from on-premise to AWS, but it also gives you the capability to migrate backwards. That means if you have a database running on AWS, for any reason, you want to replicate or migrate it back to on-premise for whatever reason, right? Database migration service allows you to do that as well. So it's a powerful feature and capability that is really key to kind of migrating databases and replicating to AWS. And then we'll outline the distributed availability group, which is kind of the hybrid architecture combining on-premise SQL Server with AWS, how the architecture looks like. And then we have Jerry from Expedia come and talk about their case study of setting up a distributed hybrid architecture on AWS and on-premise, and then how they're actually running it, what are the challenges they faced, implementation practices, testing methodologies, and then some lessons learned as well. Finally, Jerry will also show a demo which is kind of simulating their existing environment of on-premise SQL Server with a distributed availability group that's connected to AWS as well. So that's the agenda for the next hour. Okay, so when we start thinking about different options on AWS, typically when you first start with a migration project, you'd want to have the same look and feel, the same comfort, the tools that you have been always used to managing your database. For example, running SQL on AWS EC2 is exactly same as running SQL on your on-premise on a virtual machine. EC2 is a virtual machine, running on-premise on a virtual machine, it's pretty much the same, which means that you get all the flexibility and control of the database, how you set that up, the complete control of the operating system that is running the database engine, and any of the access and security and control mechanisms. But as you begin to move databases to AWS, we have customers who start to think about, okay, now we have SQL on AWS, that's fine. I want to take advantage of the AWS scale and capabilities so that I can move away from managing the infrastructure required to manage SQL Server database. For example, underlying operating system, patching, upgrading, even database patching as well, right? Automated backups. How do you manage backups with SQL Server? How do you restore? How do you set up multiple availability zone? That means active, 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 passive kind of SQL database on AWS. I'm sure that many of you are database engineers and architects in this room, and you can imagine some of the pains and challenges when dealing with having to replicate SQL database, maybe do a transaction log replication, mirroring, availability group setup and things like that. How do you failover, apply the logs, and there's definitely a lot of work involved in setting up and managing those components. That is where RDS comes into the picture in terms of AWS does manage all the underlying aspects of the database, including replication, mirroring, and whatnot, so that you can focus on the most important part, which is optimizing your database for your application and also improving your database performance. That should be the goal for users who are looking to migrate into RDS platform rather than managing operating system, patching, backups, and whatnot. And then we take one step further in terms of transformation. Again, we have a lot of customers who are in this different stages of migration, taking from lift and shift, which is EC2 based, all the way to optimization and transformation. So transformation allows you to take advantage of cloud-native database architectures. For example, Amazon Aurora MySQL, Amazon Aurora Postgres are all built natively for the cloud, although it uses the underlying MySQL binary code and Postgres as well. But Amazon Aurora was completely built for the cloud, which means it can take advantage of the scale, the distributed architecture of the AWS platform that allows you to scale at a lower cost and also be able to move away from some of the licensing that's involved with commercial database engines. A lot of our customers have also migrated their relational databases to NoSQL databases as well. For example, DynamoDB, which provides you with the scale for managing or for running your NoSQL database environment. So you think about the stages from lift and shift to optimize to transformation. Customers are at various stages in their migration architectures. I just wanted to highlight the pace of feature release at Amazon. Obviously, Microsoft SQL Server 2017 is a big deal, right? The good thing is, well, yeah, it can run on Linux. How good it can be, right? So SQL Server, imagine SQL Server, Windows users, well, they can run SQL Server on Red Hat Linux. That's pretty awesome, right? So what we have done is, in order to ensure that our customers can get the best experience and be able to take advantage of the AWS platform, we made available the SQL Server 2017 database engine on EC2 and RDS within 2 days of Microsoft announcement. So just to mention that the pace of feature release that we are trying to make sure that our customers are taking advantage of the full capabilities of the AWS platform. We have made that available in all AWS regions worldwide, and support for larger instance type. X1 type instance is pretty cool, pretty good for running large enterprise SQL Server databases. And again, with the flexible licensing option, you can bring your own license. You can use our own options, or you can also go with a license mobility option through software assurance. So all those features are made available to you today. I just wanted to quickly spend a minute on this. So relational database, as I mentioned, RDS service provides a managed database customer experience, which allows you to focus on application, focus on schema design and database, rather than on managing the underlying infrastructure, operating system, snapshots, and backups. It also gives you instant provisioning capability, scale up, scale down. That means you go with an instance type, and then maybe 1 week later you see that, hey, this database is not performing or not meeting the needs. I need to scale up to add maybe more CPUs or more RAM. You can easily scale up. At the same way, you can also scale down within a matter of few minutes to allow you to actually adapt to your changing workloads. In addition to that, as I mentioned, the licensing provides you with both bring your own license as well as license included, which allows you to run SQL Server environments cost effectively on our RDS platform. So let's compare some of the capabilities with RDS and EC2. Obviously, we don't want to force our customers to go with RDS all the time. We understand that you have certain capabilities and features that are required to be able to successfully run the database in tune, in alignment with your application. So we want to make sure that we provide the best experience for our customers, whether they want to choose with EC2 or versus RDS. So some of the high-level capabilities, as you can see that the version supported RDS, again, provides a broad range of version support. And I know that 2017 is not mentioned, but 2017 is available on RDS as well. Different editions supported here. When it comes to HA on RDS, we use multi-AZ deployment with Microsoft SQL Server, which means that you get to get the advantage of using multiple availability zones to set up SQL Server on RDS, and then underneath, AWS manages all the replication, the mirroring, and then when the primary instance for whatever reason goes down, the switchover is it's automatic, seamless. You don't have to get up at whatever time in the night and then do a failover and set up and apply locks and things like that. Everything is completely taken care of by AWS. When it comes to running the same on EC2, yes, you can do that. But of course, you have to automate. You can use always on mirroring, log shipping. There are various options that you can do. Encryption is available for both RDS and EC2. So you get the highest level of security, whether you want to do transparent data encryption or the complete block level encryption using both EC2 as well as RDS. And then both Windows and SQL Server authentication is supported. Backups. As I mentioned, our goal is to ensure that you, as a customer, you want to focus on the most important things. Backup is important, which means that AWS will manage the backup in terms of whether you want to take automated backups or manual backups and things like that. You will be able to restore all the way back to the last 5 minutes so that you can go back in time and then be able to restore at any point in time. And then few other options around replicas. So you can actually create read replicas for maybe read-intensive workloads on RDS today using DMS, or maybe using even third-party tools like Cloud Basic, for example. On the EC2 side, you can manage, self-manage, and use that as part of your database engine environment. All right, so now we just have, we took a look at some of the features with RDS and EC2. How do you choose whether RDS would be good fit, whether EC2 would be good fit? So the answer lies in usually what kind of environment you're coming from, right? What we would recommend is you probably want to look at running SQL on RDS first. At least evaluate running SQL on RDS and then see if it meets the needs, because it provides you with improved manageability at a much lower administration. Focus on tasks that bring value to your business, to your application, to the database performance, rather than managing the infrastructure again. And then typically we see often customers who are heavily developer-oriented environment or other startups, they'll probably not have the staff to completely maintain and manage different database environments. They might not even have database administrators, in which case having something like an RDS would be a perfect use case, because you're allowing AWS to manage that for you while you can focus on your code and application and some of the other important aspects. Obviously, you might want to consider running SQL on EC2 for some of those reasons mentioned there. If you want full control of not only the database, but also the underlying operating system for whatever reason, yeah, EC2 is there. When you're running RDS, when you're running SQL on RDS, you lose some of the control in terms of not be able to RDP into the underlying instance operating system. So you won't have operating system access. But really, you need to think, you need to ask the question yourself, do I need to have access to the underlying operating system? For what? When I'm allowing AWS to manage that, why should I worry about that? It increases, meaning we have often seen customers, they say that's actually a best practice from a security perspective, because we are not allowing anyone to actually log into the underlying operating system to change something for whatever reason. So it's in fact a good security practice to have a managed database experience in that aspect. But still, for whatever reason, you might just want access to the underlying operating system, in which case you choose that, and then you want to have control over maybe clustering, replication, whatnot, because the way that you have designed your current environment is the way that you are comfortable with. No worries. We are making sure that we provide the appropriate options to our customers there. And then some of the features, again, so the features, some of the lack of features on RDS is kind of a moving target. It might not be available today, but maybe in a couple of months' time, some of the features are made available. So at AWS, we always iterate some of the product capabilities and features. So I would always recommend that don't try to base your decision on some of the features and capabilities unless it's heavily dependent on the application, but rather look at from a holistic perspective in terms of what it entails to manage, to run, to do all the things, right? And then maybe some of the RDS, the instance type does not meet your need. You want maybe the highest instance type, the lowest instance type, whatnot, in which case you can look at running SQL on EC2. So Windows authentication, there are a couple of options you can look at when you're running SQL or at least Windows on AWS. You can take advantage of our managed AWS Microsoft Active Directory. It's an enterprise AD that is provided again as a managed experience to our customers, in which case you don't have to worry about setting up all the Active Directory configuration on the underlying operating system, managing a server and whatnot. That again is a managed experience, just similar to RDS. You simply launch that service and then you set up all the roles and domain authentication, and then you're good to go, right? You can be up and running in probably minutes' time. However, we also provide support for managed on-premise, right? Meaning if you have domain controllers running on-premise and then you want to have a slave controller on AWS, well, yeah, you can do that. So RDS provides capabilities for both of that. All right, so now that we have taken a look at some of the compare and contrast of RDS versus EC2, when you're actually migrating the data, again, it's important to look at, with RDS, what can you import, what can you migrate the data, replicate, what you probably cannot do. So with RDS, pretty much you get all the features of the migration options with EC2, except the log shipping and replication, and probably a hybrid architecture, right? I would imagine that something like a hybrid architecture would be coming up. So it's just a matter of time to make sure that we provide those capabilities in RDS. But today, if you're looking at migration options, you have all those options to be able to migrate data successfully to RDS platform from your on-premise and back as well, both from RDS to on-prem and on-prem to RDS. All right, so this is a busy slide, but I'll try to kind of summarize some of the important key aspects here within each of the migration methods. Obviously, backup restore provides you with a complete backup dump of your database. So you have your database running on-premise, you do a back file, dump that database back file onto Amazon S3 storage, you spin up RDS, and then you import that back file onto RDS, and then boom, there you go. So it is able to convert all the objects. Essentially, it's the backup file contain schemas, procedures, and triggers and things like that. However, you'll not be able to do a cross-engine. That means if you're trying to migrate from SQL Server to Aurora or Postgres, you can't do a back file and then import and things like that. That won't work. Import export the same way, similar. If you want to do bulk copy or selective copy from your source database and then grab that and then use that on RDS or maybe EC2, you have some of those capabilities. Pay attention to the downtime as well, right? It depends on how much downtime you have or the flexibility of your downtime. Keep in mind that in most cases you have the application dependency, and then if you are migrating from on-premise to AWS, the application should also be migrated. That's an assumption, and then you probably will have to take steps to kind of switch over the application to the AWS and whatnot, right? So those are definitely additional considerations, but you can, depending on the size of the database, you're talking about at least hours for backup restore as an offline method, right? Similarly, with import export, it can be minutes to hours depending on how you want to switch over, fail over, and whatnot. SQL log shipping can be faster if you set that up. Again, do the initial seeding. You can maybe do an initial backup to have the initial seed if for large databases, and then do the delta or the wire so that when you're ready to switch over, you just fail over and whatnot. Hybrid architecture, again, provides you that with that capability. With DMS, though, while you get minimal downtime, you can achieve near zero downtime. It also allows you to use both RDS and EC2 as a target. That means you can use both ways. And it also allows you to migrate cross-engine, which means if you're trying to move to Postgres or MySQL or whatnot, DMS with the combination of schema conversion tool provides you with that capability. The other pattern, although it's not very common, is something like an application multicast. So you have your application running, and then you have the database running, right? Existing database. That database might be SQL or even for that matter, any database, it doesn't matter. And then you try to do the same writes and updates in parallel to another database maybe running on AWS. So it's just that you're doing parallel writes to two different databases simultaneously. Again, it depends. This is more application intensive. That means you have to configure or have that application run in such a way that it can update to both locations. There's also the challenges around how do you maintain consistency. Although you don't probably need to maintain consistency between the database, which one do you want to expose to the user at what point in time? How do you ensure the data that's written here is the exact data that is written there? So there are some challenges, but it's not uncommon for customers to leverage that mechanism where they want to have their existing database running, and they also want to have a different database engine, and then just write from an application perspective as well. Maybe do selective writes and things like that. So these are the options in terms of comparing and contrasting different migration methods. You can see some of the RDS targets there. I think the only target that's currently not supported is the SQL log shipping. I would imagine, again, it's just a matter of time. But with all the option, you'll be able to easily take advantage of the RDS platform as a database target for you to easily migrate your existing SQL Server database from on-prem or maybe even running on EC2. A few best practices that I want to outline when you're thinking about migration, right? So most of it applies to both EC2 as well as RDS, but I'll probably highlight some of the more specific things here. When you have large database migration, meaning the database size is large, running into terabytes, and then you want to have a faster migration, try to provision a larger instance size. C type and then the R type are really well suited for running large database workloads, and then the new X1 instance type as well. It's pretty awesome that you have a large memory footprint and larger network throughput for you to migrate faster bits and bytes to AWS. It applies to both RDS as well as EC2. So look at provisioning a larger instance type, at least for the migration period. Once you're migrated, guess what? We have the advantage. You can always scale down to the desired instance size to run your production environment. So it's always faster, you get higher bandwidth and whatnot. And then we all know that disk performance is key for running any database workload. So look at provisioning SSD-based disks as EBS volumes, and also try to size for anticipated growth as well. So we just added the feature that allows you to scale storage scale up and down on SQL Server, which was not available until few weeks back. We just added that capability. That means you can not only scale up and scale down your instance type, you can also scale up and scale down your storage capacity. You can also scale up, you can also move from, let's say, a magnetic disk to a GP2 to an IOPS, PIOPS volume type. That means, guess what? You have now more opportunities to look at, right? You don't have to worry too much about right sizing your database, but rather, what you can easily do, some of the pattern here is now that the storage scaling is supported, you can maybe write a Lambda script, right? And then look at set up a CloudWatch alarm on your database, and then when the disk performance increases or it's close to whatever 70%, 80% disk throughput rates, set up a CloudWatch alarm that triggers a Lambda function. The Lambda function will go ahead and increase the instance size, or maybe move from GP2 to PIOPS, increase the IOPS on the EBS volume. So you get a lot of potential and opportunities to kind of play around with your workload in terms of how the workload is changing. Also for large data imports and heavy write activity, given that multi-AZ uses mirroring, that means all the writes that are applied to the primary database is also being applied to the standby database in a different AZ, which means that there is an additional performance impact on the target database, even though you might not be using that for your reads and whatnot, but still the writes can become slower because it has to write and then there has to be a copy to the secondary database as well. So again, when you are doing the migration, at least during the migration period, set up a single AZ, you can always change that to multi-AZ, and then before you switch to production environment, change to multi-AZ, and then there you go. There are some backfile import limitations you need to be aware of. At least this is only on the RDS, not on EC2. So the max size is 4 terabyte with a single file. I'm sure that there might be something more coming there. And then for whatever reason, if directly migrating to RDS is a limitation for whatever reason, maybe compliance, maybe you're not comfortable with, for whatever reason, you can always do a staggered migration. Step 1, stage 1, migrate to EC2, you get comfortable, make sure that you take advantage of AWS services. When you're ready, it's even more easier to migrate from EC2 to RDS. So you can also think that as a phased migration approach. Some of the capabilities around DMS and schema conversion tool is essentially to modernize and migrate, right? Whether you are trying to move a heterogeneous database, different database engines, or even trying to migrate across different data warehouse architectures, you can use DMS there as well. I'll accelerate my talk a little bit, given that we want to ensure that Jerry has time to do his slides and demo. So you can essentially keep your apps up and running, and then set up the replication using DMS, and then at any point in time you're comfortable, you go ahead and switch your application to the target database, and then you should be good to go. Some of the capabilities around DMS is you can actually load selectively. That's another big advantage. You have, let's say you have a big database, and then that database has years worth of data, right? You don't want to migrate all the years worth of data when you're migrating to AWS. So you can do a selective migration based on time range, based on date range. You can selectively query the data and then be able to extract the data set to AWS during migration. That provides you with a very powerful capability for you to move away from all the historical data that's residing on database, but you didn't have time to clean up that database. Now is your opportunity. When you're migrating, you can do selective migration with DMS. You can also use change data capture. That means you can have the migration running, the replication, so as the data is written to your primary database, it gets updated to the secondary copy so that everything is up to date and it's easy for you to fail over to your new database. What else can you do? You can fan in or fan out, what you call. So let's say you have many number of smaller database as a source, and then you want to combine into one big database for whatever reason, easy management, just have lower footprint of database, lower licensing cost, whatnot. Again, you can use DMS to actually fan in from multiple database source to a single target as well. Fan out. You have a large database, you want to fan out into much smaller database for management and reducing complexity. Again, you can do that with replication instance, with Database Migration Service. Take it all or some. Granular, selective, filter-based, you can run SQL queries and then extract the data based on time range, transformation rules, filter rules. There are a whole lot of options that allows you to granularly or selectively migrate your data to AWS. Some of the best practices around DMS, again, since DMS involves the replication instance where it connects to your source and the target database, making sure that you have sized the replication instance appropriately to handle your data migration needs is important, right? Again, seat instance type for large data set is very good. The higher CPU memory, vCPU count, I think the faster number of tables that can be parallel loaded onto with AWS from source to target. By default, it loads 8 tables per instance per task. You can always increase that, but try to ensure that you're not overloading your source database. Because when you create a DMS replication instance and then set that to your maximum CPU core count, and then you start the replication, guess what? It will go ahead and parallelly query your source database, extract the data, and then start replicating to target, which means the source database can become overloaded. So pay attention to when you want to balance faster migration versus better performance on your source database, especially when it's running critical production workload in source, right? So just pay attention to that, because DMS will consume all the power and the bandwidth it can to go ahead and extract all the data. It's also important to remove some of the bottlenecks on the target database. One of the important things is to disable foreign key checks, because when DMS loads a full data from your source to target, it doesn't go ahead and validate all the primary key, foreign key constraints and things like that. It will just go ahead and pull the data and then load that during the full load phase. But once it converts to a change data capture, you can go back and turn on the foreign check, enable all the triggers and other validations so that the change data capture can capture that, right? So it's important to disable some of the unnecessary things to reduce errors when you're migrating using DMS. So this is a high-level outline of the hybrid architecture using SQL Server distributed groups, which means you're essentially running an AG1, availability group 1 in on-prem, and then the second AG will run on AWS on EC2. So currently, if you want to run distributed availability group as an hybrid architecture between on-premise to AWS, you have to run that on EC2. RDS is not possible today. So this is maybe one of the reasons why you might want to run SQL on EC2. So you have your direct connect, make sure that the network bandwidth is appropriate. When you're setting up your distributed availability group, try not to do that over internet and whatnot. But just make sure that you have the necessary bandwidth, the private direct connection between AWS and your on-prem. So Jerry is going to talk more about how they've set up their distributed availability architecture using the hybrid on AWS and on-prem. So I'll now invite Jerry to come on stage and talk about his lessons and best practices. Thanks, Jerry.
Thank you. Hi, my name is Jerry Maniosi. I'm a principal engineer for Expedia. I've been doing database engineering for a while with Expedia, 2006. And lately, I've been helping out with our cloud journey. And it's exactly that, it's a journey. This is a background slide. What I would like to do in this presentation is leave you with some things that you can take away and some of the things that we've encountered and maybe some an understanding of the reason we went certain directions. We are nowhere near as done, but we have a plan moving forward, and we're slowly implementing our phased approach using a hybrid architecture. Okay, motivation for the hybrid architecture. So what this does for us is gives us a lot of flexibility. We don't want to go all in. And first, maybe I'll give you a little background on what our environment looks like. We do run a lot of SQL Server. We've historically had large monolithic applications, and over time, in the 10 years or 11 years that I've been around, it's slowly been breaking down into smaller microservices, and there's not one migration approach that we're taking to get our data into the cloud. Sometimes there are applications that we're not going to migrate. Other times, and for this particular talk, we are migrating one of the legacy ones as a start, and we are beginning with a lift and shift to make it easy. In that image where we showed two particular clusters, and we've connected the two of them, that's an asynchronous connection. And we, at some point, would then swap roles once we have enough of our stack in AWS. You'll see in the coming slides. So presentation tier, application tier being moved in bits and pieces. With that distributed group, the second cluster in AWS is serving read-only requests. So for where it's appropriate, parts of the application can read from the cloud nodes. And the idea is we want AWS applications to be reading from AWS databases, not trying to traverse back to the source on-prem data center. And we're trying to avoid data transfer costs. Let's see. So in order to, it roughly breaks into three phases. First being that we have our on-prem availability group, which is our master, and that accepts writes. And then, like I said, the EC2 in phase one would be just in read-only mode. The next phase would be to swap those roles and then send our writes to AWS, and then we're replicating back to on-prem. And then in a later phase, we would then go multi-region and then have no on-prem data center at all. That's definitely something that we're looking at to try to control costs as we go. So this is an image showing phase one. Real simple. Now, with availability groups, you have the option to configure synchronous secondaries and asynchronous secondaries. Within a zone, or rather within a region for AWS, we would have a mix. On the right-hand side, we're showing two different nodes. One of them would be synchronous for high availability. The other would be asynchronously updated for the scaling out reads, if that's what we need to do. And another key thing with this architecture and this hybrid configuration for availability groups is we're only sending data once. So regardless of the number of secondaries you have on your second cluster, there's not that many parallel streams of data traversing the wire. It goes over once, and then the second availability group reads from that that particular node. So it's efficient as far as transferring data. The next slide is basically the same thing. It's just the direction of the data is going in reverse. And our phase 2 mode would be, again, we're writing to our AWS node, but we're still maintaining our on-prem cluster. Should we run into a problem, we could switch that back. And hopefully everything goes smoothly. Knock on something. Third phase looks just like the second phase, except that it's 2 regions instead of an on-prem data center and an AWS region. Let's see. So let's get into some of the risks and some of the challenges that we had. We'll talk risks and some mitigation. So risk 1, your secondary availability group needs to be up. First of all, that's another risk that's coming up, but if we have a network bottleneck and we can't apply what happens on the on-prem data center, we can cause problems not only for stale data in EC2, but you could have issues where the primary transaction log starts filling up. What we did to mitigate that risk is to do extensive stress testing, and we did that over months. Now, through the stress testing, we found a number of things. One was there were opportunities to tune the network and increase our baseline network throughput. And I've got some slides on what we changed. The other thing that it helped us do was to find issues with the version of SQL. So availability groups is a newer feature. Currently we run 2008 R2 where you can't do that. So we started out by migrating from 08 to 16 on-prem, and so that we could leverage availability groups. Another thing that we found was we tried to do this with SQL 2014, and that's not quite as optimized as SQL 2016 with regards to the availability group feature. Things like parallel redo, we had issues with secondaries falling behind, and by using 2016 and testing that thoroughly, we were able to demonstrate that we could run like 5x our expected production traffic and then not overload the secondaries. And we watched that quite a bit. Yeah, test. If there's one takeaway, it's set it up and test it. And let's see, and also through that stress testing, we found some bugs. A new version of SQL worked with Microsoft. They had already had some issues, like we found access violations, a couple other things. But we came up with a recipe, and we know what patch level we need to be at to make it all work. Here are some performance counters. So we watched in our testing log bytes flushed per second. That's essentially how much is the database changing. With availability groups, there's the concept of queues. There's a send queue, which is basically data that's on the primary that's not yet been applied to the secondary copies. And then a redo queue or a recovery queue. And same concept there. It's just logs that have been sent to the secondary, but they're not applied yet. So if you ran a query, it would be behind. And we mitigated these risks by, again, stress testing and just like turn it until it breaks, and then is that adequate, or do we need to scale more or come up with a better solution? And I can say that we also found opportunities to tune the database and rethink what it's doing. For instance, there's sometimes logging that your application does to the database that could be going elsewhere, or maybe it sort of depends application by application. But we reviewed things. In case we want to be on a different platform someday in the future, we wanted to sort of simplify what the database does. So things like the change data capture feature within SQL, we are using, but we don't need to be necessarily. So in addition to the cloud migration, it's thinking about what can we change so that when we're in AWS, it'll play nicer. We'll have hopefully fewer issues. Here's some perfmon charts. We regularly collect the perfmon counter is run it through the PAL tool, and that's what's generating these charts. And the PAL tool is available from Codeplex still. I think it's under a different name now. And here we're looking at a redo queue, for example. Ideally that's going to be 0 or near 0. If it's not, or if it starts ever increasing, then you want to look for resource bottlenecks and figure out why is it taking so long? Do I need more network bandwidth or bigger instance size? Those types of things. Hybrid strategy will come to a halt if there is an AWS Direct Connect failure. Yes, and Mr. Vogel's everything fails all the time. So you have to look at, or we needed to have redundancy in our infrastructure to protect against stuff like that. Worst thing that could happen would be that breaks and then transaction logs fill up on the primary, and then we've got a mess. So that's another consideration. Third risk, again, everything fails all the time. We expect EC2 nodes to fail from time to time, or have to be prepared if and when that happens. So what we're working on now is maturing our scripts and automation in order to detect, obviously, when nodes fail, and also be able to rebuild a node quickly. So it's a little bit complicated with SQL compared to a platform like Mongo, because you've got server-level objects and things that you need to manage. If you're using SQL agent jobs, for example, if you build out another node, you need to bring those along with it. So we've done projects like developing clone processes to store all the stuff, almost like metadata for an instance, and then be able to rehydrate it on a new build. And if everything goes well, we could have self-healing clusters, maybe develop a service that watches for health of the nodes, and then automatically auto-scaling group generates a new EC2, and then automation joins it to the cluster, and then it starts the seeding process until it's ready. That way we're prepared if there's a failure. And we already have redundancy in that we would be in multiple availability zones. It's not that we would expect one machine to just stay up all the time, but it's that having to get a DBA to take action in the middle of the night. Obviously we want to have good, solid, mature automation, and those are some of the projects that are going on right now. So we are trying to prepare for failure, essentially. Okay, implementation guidelines, best practices. So based on our stress testing results, we can dial in on what instance type we should be going with. We're trying to pay a lot of attention to cost. We don't want to over-provision, although, yeah, there are options to scale up and scale down instance type. This particular set of applications that we're starting out with, these are production, booking path, super critical, super latency sensitive. That's why we're taking a very cautious approach, and it may be that if we take a snapshot of an EBS volume that we're upsetting the application, or we're causing some end user to have a frozen screen while they're trying to buy something, and we obviously don't want bad customer experiences, but we also don't want to over provision if we don't need to, and I imagine that there will be other automation projects to automatically right size, assuming that we've got enough additional capacity within our availability groups. We need EC2 instance types with better network performance, and we did evaluate our RDS. We are currently leveraging some features of SQL Server that don't, or not currently available in RDS, and we can revisit that later, once they become available. Another thing we ran into is the use of dedicated hosts. So this is mostly due to cost. So SQL Server licensing is not cheap, and it's gotten more expensive. So until we're on a different platform, what we can do, or if and when that happens, I don't know. But by using dedicated hosts, you have the option to, well, also we're trying to bring our own license. We've got a tremendous agreement with Microsoft, and when you deploy a dedicated host, meaning that you're the only tenant that's on the hardware making up the VMs or making up the EC2s, we expect to avoid noisy neighbor situations, but also it allows us to just license the physical cores on those dedicated hosts, and that adds up to quite a cost savings. So if you're concerned about managing costs, you may want to look into that. And as mentioned, this is database, so you're pretty much always going to be running into storage, or you want to ensure that your storage can keep up. So provisioned IOPS would be the standard, except for cases where everything can fit into memory, or that's low write activity, or that type of thing. So next, Windows settings. TCP auto tuning level, receive auto tuning level should be set as normal. And, that slide's a bit hard to read, but we reviewed receive side scaling state, chimney offload state, net DMA state, direct cache access. These were pretty well normal. Next slide was the one for other NIC settings that we changed. This is interesting. We initially found in our baseline testing that we could push 2.4 gigabits per second over our direct connect. Once we were done making changes to EC2 network settings, we were able to get that up to 9.5. So making sure that we don't fall behind and that the secondaries stay up, approaching it through network tuning, as well as reducing the amount of work that the database has to do by getting rid of certain features, both together helped us out quite a bit. And we looked here at interrupt moderation, disable jumbo packet 901 for priority packet and VLAN, packet priority and VLAN disabled, and receive and transmit buffer at 2048. Okay, current state. So we're still in our phase one. We have a couple production nodes that are serving read queries. We obviously will, this application is a number of machines. It's actually a sharded database platform. So we've moved a couple shards over to get started. We will continue with that and then work closely with Microsoft in the event that we uncover any more additional bugs, although that happened several months ago during initial stress testing. We will be refining automation and building more resiliency as we go. I think of it as we've got a build process that takes X amount of time. So how do we get that down and keep chipping away at it to get it down to seconds or minutes instead of hours. I'm excited about the Linux or the opportunity to run SQL on Linux, and I think that's going to play nicely with future automation that we're going to do. And it certainly, you can install SQL a whole lot faster. So let's see. And then once we're fully built out and provisioned, and we trust that we can do all of our functions and monitoring's working in the backups, so this is a very complicated application, and we won't be able to go to phase two until several bits of work happen in our application layer. And there's maybe like 30 dependent services just on this one set of shards. So we're at the mercy of our application teams to get those changes implemented before we can consider sending our writes to AWS, but that's the roadmap. So let's see. Okay, I have a demo. It only takes about a minute. It's really simple. And let's see if this works. Okay, so I'm going to get this started and I'll hit pause real quick. All I'm doing in this demo is I'm using Management Studio as a client. I have a distributed availability group that's configured in our lab environment. So this top section here represents the objects locally in our on-premise data center. And then this bottom one is an EC2 machine that's running, and it's connected in that the way that the architecture diagram showed, the availability groups. So the top one basically is going to asynchronously update the bottom one. I've done just a quick little script here showing that where everything's going to go in one shot. So when I hit go, it's going to first query a value in a table locally and then remotely. Then it's going to update some data. Then it's going to repeat that query locally and remotely. And then what I'm looking for is that bottom value to reflect that it's in sync with the on-prem data center. So it's pre-recorded, so I know it works. So I'm just tracking what the names are. I'm, in this case, using a linked server connection from the on-prem to the remote. It was just easier to do it in one window. I have a table that's called system value, which has a column called system value value. And the first part of this is it's just going to update it to 1, so I know I've got a consistent starting point. Then I'm going to go to system value value, and I'm going to change it to 2. Now if I hit go, I expect that the second one, you can see that the local one changed to 2, but the remote one did not. So how come? Wasn't exactly expecting that at first, but it makes total sense. The way this script is running, it's firing those queries right after each other. So it basically sent the update and then ran the query on the remote host before it had a chance to get it. So there is some latency in this connection, and that's a good demonstration of that. So in this case, I just reran the query and it showed up. So it actually did the same update twice, and because it's an update, it didn't change anything. So. That's it. There's some work involved in getting the, let's go back here. Oops. Yeah, we're back. Yeah. Okay. You want to do it at the end? Go ahead.
I just want probably to complete this slide, and then we can just take the question. Just one slide.
Sure.
So thanks, Jerry. I just want to also highlight some of the related sessions that you might be interested in. Maybe some of the sessions have already passed, or you might have attended some of the session, but these are related sessions that will be hugely useful to you. There's a workshop for migrating Microsoft SQL database to AWS. And then we have a breakout session of designing. So we talk about migration strategies in this session. And the WIN306 will talk about design. Now that you've already migrated, how do you design, optimize running SQL on AWS as well? So that's the next phase. I think that will be useful to you. And then we also have a chalk talk on multi-region SQL Server clusters using different AWS regions, using HA and DR. What are the key things to consider there? That's again a chalk talk where we'll do a whiteboard and have a Q&A and things like that, more interactive kind of session. So I highly recommend that you attend that. I think there's a repeat session on Thursday evening, and I'm also will be in that part of the chalk talk as well. And then finally, if you are interested in more deep dive on directory services and how to integrate directory services with other AWS SQL Server and Windows environments, WIN403 is pretty much very strong there on deep dive patterns. So just take a look at your schedule and see if some of those sessions interest you. Also, just request you to complete the evaluations on the session. Hope it was useful to you, for you to take back away some key learnings that you can apply to your migration projects, or even looking at considering a hybrid distributed architecture as well. With that, thank you very much, and maybe we can take the question. Thank you. Good question. So I'll try to repeat the question for everyone. So the first question was, what's the recommended instance type for SQL Server? And then the second question, so I'll try to answer the first question. So the answer is, again, meaning it depends on how much, what's the kind of database size and what kind of read-write activity you're trying to expect, whether you want to have maybe a read-heavy workloads versus write-heavy and things like that. Typically, what we have seen with enterprise customers that get the best out of SQL Server are running instance type that are more compute intensive and memory intensive, that has optimized network bandwidth. Higher the network bandwidth, the better SQL Server performance, because guess what? When you have higher network bandwidth, it also has a dedicated network bandwidth throughput to your EBS storage. Given that EBS storage is a network attached storage connected to your instance, Having an EBS optimized, higher network throughput performing instance type always performs better because it has two network paths. One network path for your user read-write activity, and then one backend network path to your EBS volumes from your EC2 instance. The newer instance type, the X1E, is awesome. We have had extremely good feedback from customers on the X1E instance type. So I would highly recommend that you start with X1 first and then maybe look at C and R. But C, R, look at network throughput, and then any of this instance type, I don't think you can go wrong. Your second question was EBS volumes in terms of how do you, traditionally with SQL, any database, even with Oracle database, SQL database, you always have that DB files, index files, log files, whether you want to have different drives and things like that, different storage and things like that, right? On AWS, it does not really matter significantly because you still have one network channel to the EBS volume. Just because you have 3 EBS volumes doesn't mean you have 3 network channels to EBS. It is still one network channel to EBS volumes, which means it is going to share the read-write to the backend EBS volumes. So it's not significant that you need to separate out index, temp DB, and things like that. But yes, yeah. So that is, I think, definitely a recommended option. If you have temp DB and then the instance type supports ephemeral storage, then go with it. It always gives you better performance because instance store is locally attached to the instance as opposed to EBS volumes, which is network connected. So you get zero cost because you are not paying for the instance store, right? It comes with the instance type, so there's no cost. Those are all SSD volumes, which means you get higher performance, and those are directly attached. So all three is a win-win situation, especially for TempDB. Yep. Sorry, I just missed the last part. Well, yeah, meaning certain instance types does support and certain does not. So I guess you just have to carefully see whether you really have a strong requirement to use instance store for TempDB for your database performance, in which case you have to look for instance type that supports instance. Yeah. What kind of jobs? Yeah, SQL agent. I think that is one of the requests from large number of customers to be able to get that feature. We don't have that capability, but depending on customer prioritization and need, we might just add that.
I think there is some support. I think you can run some jobs if you script it, if you run if you generate the T-SQL, but it's not as friendly as what you would be used to.
The client side, yes, the SSMS and other things are there. But if you're wanting to run some jobs and things like that, as Jerry mentioned, it's not really as intrusive as you can do with EC2 on SQL because you don't have all the necessary permissions on RDS to be able to achieve that functionality.
Yeah, and certain jobs that would require stuff like access to the OS or command shell, or it have to test.
Yeah.
See if it works.
Yes.
Do you need to be in a VPC to support AD authentication?
Do you need to be in the VPC to support AD authentication? The answer is yes. The RDS, essentially RDS runs in VPC, right? Okay, oh, the classic, the old classic, okay. Yeah, I think you'd probably need to run that in VPC because Microsoft AD, are you trying to use the managed Microsoft AD on AWS or domain controllers?
Well, no, it's just, we'd love to use AD.
The managed AD?
And obviously, you guys are very much like, could you please move that?
Yeah. Yeah, I think, yeah, with Classic, given that it's an older platform, we are trying to ensure that the customers can take advantage of all the good features.
AD authentication in a VPC.
Yes.
In RDS.
Correct. Yeah. All right, I think we are probably out of time. So thank you again very much, and hope you enjoy the rest of your day. Thank you very much.